Welcome to Maths 123. In this video, we are going to discuss about trigonometric ratios. For that, we need a right angle triangle. So I have taken this right angle triangle ABC here. We know in a right angle triangle, for any acute angle, the side opposite to the acute angle is called the perpendicular. So here let me take this acute angle C, which I have taken as theta. The side opposite to this theta is AB, and this AB is known as perpendicular, which I am going to represent with B. The side adjacent to it, means the side adjacent to it is CB, is known as base, and the side opposite to this 90-degree angle is known as hypotenuse, which I am going to represent with H, and base I am going to represent with B. So in this triangle, AC is my hypotenuse, CB is my base, and AB is my perpendicular. So the ratio between the length of pairs of two sides of a right angle triangle is called a trigonometric ratios. Means the ratio of any two, it can be hypotenuse divided by base, or it can be the ratio of base and perpendicular, and these ratios are known as the trigonometric ratios. And we have three sides of triangle: hypotenuse, base, and perpendicular. And right angle triangle give 6 trigonometric ratios, and these 6 trigonometric ratios are, so first ratio is sine, which mostly we represent with SIN. Sine of this acute angle C is equal to perpendicular P divided by hypotenuse, which is equal to H. So here perpendicular is equal to AB and hypotenuse is equal to AC. So second ratio we have cosine, which we mostly represent with cos. So cos of angle C is equal to base, which is B, divided by hypotenuse. The base here is equal to BC divided by hypotenuse is AC. Third ratio we have tangent, which we mostly represent with tan, and this tangent is equal to tangent of this acute angle C is equal to perpendicular divided by base. So here perpendicular is AB and base is BC. So fourth trigonometric ratio is equal to cosecant. We mostly represent with cosec, and cosecant of angle C is equal to 1 divided by sine C. So which is equal to hypotenuse divided by perpendicular. So hypotenuse is equal to AC divided by perpendicular, we have AB. So the cosecant C is a reciprocal of sine C. Next we have fifth one, which is secant, and secant we represent with SEC. So secant of angle C is equal to the reciprocal of cos C. So it means this will be equal to hypotenuse divided by base. So hypotenuse is AC and base is equal to CBC. Next, sixth tangent, and we represent it with cot. So cot of angle C is equal to the reciprocal of tangent C, this one. So this is equal to base divided by perpendicular, which is equal to BC divided by AB. We can use this to remember all trigonometric ratios. Pandit Badri Prasad har bole. Sine C, from here we'll take P, and from here we'll take H, which is P upon H. Similarly here B upon H are cosine, which is equal to B upon H, and from here we'll take P and B. So this is our tangent C, which is equal to P upon B. And other three trigonometric ratios you can derive from here, because we know the cosecant C is the reciprocal of sine C, and secant C is the reciprocal of cos C, and cot C is the reciprocal of tangent C. To solve all the questions related to trigonometry, these ratios are very important. So you should remember all these ratios by heart. So we have written all the trigonometric ratios with respect to angle C, this angle. Suppose we have to write the trigonometric ratios with respect to this angle A, then the perpendicular and base will interchange. Let's see how. Now we'll write all the trigonometric ratios with respect to this acute angle A. The side opposite to this A will become the perpendicular. So this will be my perpendicular this time. Side adjacent to this angle is this. So this will be my base, but hypotenuse will be the same. So now we can write sin A, first trigonometric ratio, sin A is equal to perpendicular, which is P, upon hypotenuse. Here perpendicular is BC divided by hypotenuse is AC. So second, cos A is equal to base divided by hypotenuse. Here base is, now this time the base is this AB divided by hypotenuse, which is AC. And third one, we have tangent A, which is equal to perpendicular divided by base. The perpendicular here is C divided by A, B. So other one is cosecant A is equal to the reciprocal of sin A, which is equal to H upon P, which is equal to AC divided by BC. Fifth one is secant A is equal to the reciprocal of cos A. So this will be hypotenuse divided by base. So base here is, hypotenuse is AC divided by base, which is AB. And sixth one, we have cot A, the reciprocal of tangent A. So this will be equal to the base divided by perpendicular. So here be divided by perpendicular, which is BC. So like this, all the ratios will change now. Now let's see the relation between sine, cos and tangent. The tangent C is equal to perpendicular upon base. Now let me divide the numerator with H and base with H. Then this will become P upon H divided by base upon H. Perpendicular upon hypotenuse is equal to sine C. And what is this? Base upon H. The base upon hypotenuse is equal to cos C. So this implies that tangent C is equal to sine C divided by cos C. So this is the formula, and this is a very important formula. So similarly, we can find out cot C. We know the cot C is equal to the reciprocal of C. So this will become cos C divided by sine C. So you have to remember these two formulas. These are very important.